Dear students, today I will discuss the second application of the dimensional analysis. Last class we have discussed the first application. That means to check the correctness of a formula. That means whether a formula is dimensionally correct or not, we have seen. That was based on the principle of homogeneity of dimensions. That means the dimension formula for each and every term will remain same for an equation. Now we are going for second application, that is to deduce the relationship among various physical quantities. Let us say centripetal force. And centripetal force acting on a body when it moves in a circular path depends upon mass of the body, velocity of the body, radius of the circular path. And what are the powers of these variables? That is, what is the power of velocity, what is the power of radius, what is the power of the mass? That we can find on the basis of dimensional analysis. You may take another example. Suppose time period of a simple pendulum. Experimentally, it is found that the time period depends upon the effective length of the pendulum, acceleration due to gravity. But what are the powers of these two terms that can be found from the dimensional analysis? This is also based on the principle of homogeneity of dimensions. Homogeneity means homogeneous, same everywhere. That means each term of the equations would have the same dimensional formula. Right? Let us solve one example. Suppose it is given that the time period of a, let us solve that question. The time period of a simple pendulum depends upon the effective length of the simple pendulum and acceleration due to gravity. Suppose time period is represented by symbol t, and t is suppose proportional to L to the power a. L is the effective length of the simple pendulum. And second factor, suppose t is proportional to g to the power b. We don't know the values of a and b. And the values of a and b we can find from the dimensional analysis. What is the value of a and what is the value of b? Experimentally it is found it depends upon L and G. Now, if you combine these two, what you will get? T is equal to some constant K, L to the power A, G to the power B, because T is proportional to L to the power A and T is proportional to G to the power B. And according to principle of homogeneity of dimensions, the dimensional formula of the left hand side must be equal to the dimensional formula of the right hand side. So let us write the dimensions or dimensional formula of each and every term on the right hand side. And here K is a dimensionless constant. So its length means you can write L to the power A. G is acceleration. Acceleration due to gravity. So it will have the dimensional formula of acceleration. So I can write L t to the power minus 2 to the power to the power b. That is equal to L to the power a plus b t to the power minus 2b after simplification. In the left hand side, it is you can write like this: m0, l0, t1. Mass is not there, length is not there, time is there only. So t to the power 1, m to the power 0, l to the power 0. Right hand side mass is also not there. So m to the power 0. Now, as these two sides represent the same quantity, that means the dimensional formula of left side must be equal to the dimensional formula of the right side. Now let us equate the powers of the fundamental quantities. Powers of mass are not there, 0, here also 0. Here power of length is also 0, here power of length is L A plus B. Now equating the powers on both sides, what will get? A plus B equal to 0. And if you equate the powers of t, so 1 is equal to minus 2b. So if 1 is equal to minus 2b, b is equal to minus 1 by 2. Now what about a? A plus b equal to 0. So a minus 1 by 2 equal to 0. So a is equal to 1 by 2. So after simplification we have got the value of b is minus 1 by 2 and value of a is plus 1 by 2. So after solving, I will put the values of a and b. What I will get? So that is equal to k l to the power 1 by 2 g to the power minus 1 by 2, or I can write k root over l by g. And experimentally it is found that value of k is 2 pi. So t will be equal to 2 pi root over L by G. So this is the expression for the time period of a simple pendulum. We have derived on the basis of dimensional analysis. So using dimensional analysis, we can derive a number of formula if you know the factors on which it depends. And one more important thing, you remember, the proportional constant cannot be found on the basis of dimensional analysis. That is one of the limitations of dimensional analysis. This is the procedure how we can find the relationship among various physical quantities using dimensional analysis. Now let us solve another question based on this application, that is second application. We will deduce a relationship among different physical quantities. Now suppose a planet is revolving around the sun in a nearly circular orbit, and it is found that the time period of revolution of a planet depends upon the universal gravitational constant, mass of the sun, and the radius of the circular orbit. On these three factors it depends, and it is given that so that t square, the time period, square of the time period is proportional to cube of the radius of its circular path. That we have to show on the basis of dimensional analysis, and also we will write the formula for its time period. So now, as it is given, the time period of revolution depends upon t is proportional to mass of the sun, suppose m to the power a, gravitational constant g to the power b, and the radius of the orbit to the power c. We can write t is equal to k is a proportional constant, g to the power b, r to the power c. As usual, you will put the dimensional formula for each and every term. So k is the mass, no problem, it is m to the power a. Gravitational constant, what is the dimensional formula? m minus 1 L3 t minus 2 to the power b, and radius is another length L to the power c. Now simplify and write the powers of all individually. So m to the power a, and here minus 1 into b minus b. And what about L to the power? L to the power 3b plus c. And t power, here only one t is there, minus 2b. So now we have got the powers of m, l and t. Now in the left hand side it is only time, so m0, l0, t1. So according to principle of homogeneity, the dimension on both sides will remain same. So power of the fundamental quantities will remain same on both sides. So equating the powers of mass, length and time on both sides, what will get? A minus b equal to 0, and L to the power 0, here L to the power 3b plus c. So 3b plus c is equal to 0 and t is 1. So here t to the power minus 2b, so minus 2b equal to 1. So you will get directly b is equal to minus 1 by 2. And if you put the value of b here in this equation, a minus, so a is equal to b, because a minus b equal to 0, so a equal to b. So b is minus half, a also minus half. Now you have got the values of b and a. Now what left? Value of c. Just put the value of b here, you will get the value of c. So 3 into minus 1 by 2 plus c is equal to 0. So c equal to 3 by 2 after solving. So after solving, what you have got? A equal to minus 1 by 2, b is equal to minus 1 by 2, c equal to 3 by 2. Now you have got the powers of mass, powers of a mass and gravitational constant and radius. On putting the values now, what you will get? So t is equal to, we can write k m to the power a, m to the power minus half, and g to the power b, g to the power minus half, and r to the power c, r to the power 3 by 2. And if you take the square on both sides, what you get? T square equal to k, the constant, no problem, it remains k also once again, m to the power minus 1, g to the power minus 1, and r to the power 3. And mass of Sol and gravitational constant, those values are fixed. Now I can write T square is proportional to R cube. So this is the proof it was asked. It is shown that on the basis of dimensional analysis, the T square is proportional to R cube. And if it is given to find the write the formula for time period, and it is given k is equal to 2 pi. Experimentally it is found. So t will be equal to 2 pi root over r cube by gl, because all the power are half. So I have written root over, so r cube in the numerator, r cube root over means r to the 3 by 2, m minus 1, g minus 1. So this is the time period of revolution of a planet revolving around the sun in a nearly circular orbit, and it is shown that a square is proportional to r cube. So these are the methods how to solve this type of questions, and I will give you some questions and you will solve it.